All right, so we are starting this next unit, and it's more about equations and inequalities. Okay, we will revisit expressions a little bit, but now we start moving into other parts, equations and inequalities specifically. This first lesson is on solving one-step equations. So you need to make sure you've got something to write with, you have your video notes in front of you. My reminder would be to be an active listener, pay good attention, make sure you are watching and listening. And also make sure you pause when needed so you can try some of these on your own to see how you're doing with this concept. All right. That being said, let's kind of look at some of the big ideas. In this unit, one of the big ideas is this bottom bullet point right here. An equation has one solution. You're going to see that in action today. Okay. Equations are designed to just have one solution. So let's get right into it. All right. Well, solving one-step equations, you can see here a picture of some balance beams. Well, solving an equation is like balancing a scale. Okay, when you have a scale balance, you know that both sides have the same weight or they have the same value. Well, in this situation right here, we want both sides to remain equal. They should always be equal because the scales should be balanced. So if we look at this picture on the left right here, you see some values over here, you see some shapes. Well, what would it take to make this side have the same weight? Well, it would take the same values. Okay, so if we have 2 circles and 3 triangles over here, well, that would be balanced with 2 circles and 3 triangles over here because now they have the same weight, same value. If you think of this like a simple math problem, well, if this side has a weight of 7, and this side was a problem of 3 plus something, you got to remember this you want to be equal to that. And if we want this to be 7, there's only one value we can plug in there to make that true. And that value would be 4. Okay, now these scales would be the same. They'd be equal. If I had a different number here, like 3 plus 2, well, that's not 7. So the scales would be imbalanced at that point, and we don't want that. In math, you want things to be equal. So we're going to kind of think of the balance beam as we move through this today. Now there are a few steps to get us going here. The first step, the variable must be alone or isolated on one side of the equation. You're going to see some examples here shortly, and our goal will be to get the variable all by itself. Okay, that'll help us solve for it. The second step, we want to isolate the variable by using inverse operations, or sometimes we just say the opposite operation. So that's how we're going to get the variable by itself. We use inverse operations. Third thing, the equation must remain balanced. We cannot create a new imbalanced one. We have to make sure things stay balanced when we're solving a problem. And the bottom reminder would be always check our solutions, just to make sure that our value is actually the one that works for that problem. Now, I just mentioned inverse operations. Well, there are 4 operations in math: addition, subtraction, multiplication, division. We know that. Well, we also now know that each operation has an inverse operation, and that's the operation that undoes the other one, okay? We use it to undo each other. For instance, the opposite of addition would be subtraction, because we can use subtraction to cancel out addition. And the opposite of subtraction would be addition. So we would say these two right here are inverse operations of each other. The same can be said of multiplication and division. If I want to undo multiplication, I would do division. Or if I want to undo division, I would use multiplication. Okay, so get used to knowing that these are inverse operations. Inverse just means the opposite one, or the opposite of that. So we know that these go together. We've learned that over the years, and now we're going to apply that today to help us get the variable by itself. Now, before we look at some of these problems, sometimes we can think very easily, well, I can do this in my head. This is very easy because I know what number minus 5 equals 18. Or I know what number plus 17 equals 74. I can do this in my head, and that's good. That's fine. But I will challenge you to make sure you're understanding the steps as we go today. And the reason you want to understand the steps is because we're starting very simple right now with one-step equations. Okay, one-step equations are really just examples of this one, or this one, or that one, where you just have to do one thing to get the variable by itself. We call those one-step equations. But if you go beyond that, you then move into two-step equations. And those aren't so easy on our brain. Okay, now we have to do a couple things to get the variable by itself because there's addition and then there's also multiplication. We want to undo those. Okay, so it gets a little more complicated with two-step equations. It also gets then into multi-step equations where we might have a lot of things going on. And now we really have to kind of know what to do. So I show you this just to bring us back to this thought right here. Know how to apply these operations so that we can undo and get the variable by itself, okay? Because it's one thing to know it in your head, but it's another thing to know the steps that you can use no matter whether it's a one-step problem, a two-step problem, or a multi-step problem. You want to kind of know the steps to follow. So with that being said, of where this goes eventually in 7th and 8th grade, let's now look at some of these one-step equations. All right, if we start with a few of these together, let's look at this first one. B minus 5 equals 18. Now, again, the goal is to get the variable by itself. Well, the variable is right there. And you got to ask, what is happening to that variable? And we're subtracting 5 with it, okay? So what we want to do here is we want to do the opposite of subtracting 5, which, again, the opposite of subtracting 5 would be adding 5. So we really want to add 5 to both sides of the equal sign. That's part of keeping it balanced. What we do to one side, we have to do to the other. Now think about what happens when you have b minus 5 plus 5. You really have these two things that kind of cancel out, right? If you take away 5 and add 5, you're back to where you started. So that's the whole point. We want to get the variable by itself, and the way we do that is we do the opposite of what's being done to it. But again, we have to do it to both sides, which is why over here I have 18 plus 5 still. So now I can kind of figure this out. Well, the minus 5 and the plus 5 cancel out, and I'm just left with the variable by itself. And over here, I solve that part too, and I get 23. So I've really just kind of established that if I add 5 to both sides, I find the value of b. And we always want to check that. Okay, so if I plug in and if I go back to my problem here and say, you know what, let's plug it in just to make sure, 23 minus 5 would be 18. And you can check it on the calculator, you can check it in your head, you can check it on paper, but that is how we solve a one-step equation. We do the opposite of what's being done to the variable. Let's look at the second one. X minus 5.6 and it equals 25. So again, ask yourself, how do we get the variable by itself? Well, right now, we're subtracting 5.6 from the variable. And you want to do the opposite of that. So you want to add 5.6 to both sides. Okay, so if I add it over here and add it over here, I'm really kind of creating a new problem that looks like this, x minus 5.6 plus 5.6. That's what that really is. And over here, I still have 25 plus 5.6. I got to add 5.6 to both sides of the equation. Now, again, we know these cancel out, okay? We know that those cancel out. We're isolating the variable. We're getting it all by itself, so we're left with x. And over here, we would get 30 and 6/10. So that's what this side would equal. Okay, so we've isolated our variable. We got that value, and we always want to double check to make sure it works. So I go back to my problem. I plug in 30.6 for x, and I solve that 30.6 minus 5.6. And again, I can do different ways to get that, a calculator, my head, do it on paper, but I end up with 25. And if I see that that's true, then I know I've done it right. Because again, remember that big idea, equations will have one solution. Okay, variables will have one solution when you're solving these. All right, look at the third one. Now we are doing the variable plus 17, and it will have a value of 74. So something plus 17 is 74. Again, think, how do I get that y all by itself? Well, do the opposite of adding 17. Do the inverse operation of adding 17. Well, the way we cancel that out is we subtract 17. So on both sides, we want to subtract 17. And if we do that, we're kind of left on the left side now. We have a y. Notice I did not show this step at this time because I wanted us to show it in the first few. But now if I cancel out the plus 17 with a minus 17, I'm left with y. And over here, if I subtract 17, I end up with 57. So my hunch is that the variable will be 57. So we want to plug that in now and double check our work. So if I do that, 57 plus 17, I get 74. It does check. So I'm doing that one right. They sometimes bring fractions into play, okay? Because really something plus 3/4 equals 7/8. Well, how do I get the variable by itself? You do the opposite of adding 3/4. Well, that would be subtracting 3/4, but do it to both sides. I want to get rid of the 3/4 over here, so that will take care of itself, and I'll be left with a variable. But I also want to subtract 3/4 from the other side. And if you do that, you got to think about subtracting fractions, because really you want to do 7/8 minus 3/4. I wrote it out here just to see what we're doing. And I know that I should probably make this an equivalent fraction for that one, since this has an 8 down here. So really, if I double that fraction, I get 6/8. So 7/8 take away 6/8 would be 1/8. So that is essentially the value of my variable. If I go back here and look, that would be saying, okay, P has a value of 1/8 plus 6/8. Well, that is 7/8. So P's value is 1/8, all right? So sometimes they give you whole numbers, sometimes they give you decimal numbers, sometimes they give you fractions. It brings a lot of skills that you've learned over the years into play with this concept right here. Now, I want you to try these next 4 on your own. Again, remember, get the variable by itself and then use inverse operations to help solve for what its value really is. Pause the screen and do these for yourself. All right, check your work here. This is where you can see my steps. Usually underneath it, the first thing I did was I wanted to undo the operation. So they're adding 63. I want to subtract 63 from both sides. And when I do that, I find that the variable d has a value of 42. And then down here, I was checking it to make sure it worked. Plug your value back into the problem and do 63 plus 42. And if you get 105, then you know you did it right. Okay, so solve for the variable and then check your work. That's what you can see for each of these. So if you need to look over this work here, go ahead and pause. But remember, they threw some fractions at you, and they threw some decimals at you. So you want to be comfortable with those skills along the way. Okay, you're in 6th grade. That's the expectation that you can solve one-step equations with irrational numbers. All right, let's look at a few more together, because the last ones were all addition and subtraction. Well, now let's talk about multiplication and division. Again, those are also inverse operations. So if we start with this first one, y divided by 4 equals 14. Well, what's the opposite of dividing by 4? That will be the first thing we want to do, and you are right, that is multiplying both sides by 4. So I do it to both sides, because over here, that will cancel out, okay, and I'll be left with just the variable, all by itself. I have isolated the y, but I still over here will do 14 times 4. And I am left with y has a value of 56, okay? And that's what 14 times 4 was. So y is 56. Now you want to check your work, okay? And if I do 14 times 4, that would be 56. But if I used like division to check the problem here, because really this is a number divided by 4, and we think it's 56. So if we solve 56 divided by 4, we would get 14, okay? So that's just our way of checking it right there. In the second one here, 36 is equal to 4z. Well, don't forget that when a variable and a number are side by side, that means we want to multiply them. So 4 times z is 36. The way we get the z all by itself is we divide by 4. We want to divide both sides by 4, because that's the inverse of multiplying by 4. And if I divide both sides by 4, well, over here, those 4s cancel out. 4 divided by 4 is 1. Okay, it kind of goes away. I'm left with 1z. Over here, I'm left with 9. So really, I'm thinking 9 is the value of z. Okay, and we can always plug it back in and see if that works. Okay, I just know 4 times 9 is 36. So this one checks out just fine. In the third example over here, now we're doing a division by a fraction. So y divided by 2/3 equals 4. Well, how do we get rid of dividing by 2/3? We do the opposite, which is multiplying by 2/3. So I multiply both sides by 2/3 times 2/3 times 2/3. Now, these will cancel because that's what inverse operations do. They cancel out dividing by 2/3. So what I still have to do over here, though, is I have to do some multiplication now with 2/3. So I got to do 4 times 2/3. Well, I made the 4 over 1 and then the 2/3. So now I can multiply my numerators and get 8. I can multiply my denominators and get 3. And I really have found that value right there to be 8/3. Now, some of you might want to change that back into 2 and 2/3, which is okay. 8/3 is okay. 2 and 2/3 is okay. But we want to check our work to make sure that this really works for y. Now, if I think about this, if I write this out like this, 8/3 divided by 2/3, I mean, I know 2/3, like I know 2 goes into 8 4 times. So like 2/3, 4/3, 6/3, 8/3. That's where this came from. Okay, so it checks out just fine. Y's value is 8/3 or 2 and 2/3. This one up here, 10 and 8/10 is equal to 1 and 2/10 times h. So we want to get the variable by itself. And right now it's being multiplied by 1.2. So we want to divide it by 1.2. Divide both sides by 1.2. That will cancel out this. You'll have the variable by itself on the right. But on the left, if you actually solve this right here with a calculator or on paper, you end up with a value of 9. So what we're saying here is that the variable's value has to be 9. Now we can check this and prove it. If I plug this back in for h, that would be 1.2 times 9. Okay, and I just worked it out right here, and I end up with that solution. So it does check just fine. Remember, decimals and multiplying, there's a few things that went on there that hopefully you remembered there. All right, these next 4, I want you to try these on your own. And again, pause the video and then turn it back on when you're ready to check. All right, here are your 4 answers for that. In the first one, y had a value of 192. In the second one, p had a value of 3.5. In the third one, there was some fractions. There was a lot of work. X had a value of 31 and 2500ths, or 31 and 1/4. Think of it like that. And this last one here, W had a value of 81 and 2500ths, or again, 81 and 1/4. So if you need to pause to look over your work and look over this work and see where you might have gone off track, or if you weren't sure what to do, now is a good time to pause and just take a closer look at your work. And when you're ready, go to the next slide. All right, so there have been a whole bunch of things that we've been talking about in this particular lesson. So I want to bring it back with some important rules for solving equations. The first one, rule 1, when you solve an equation, your goal is to get the variable all by itself on one side of the equation. In other words, you are trying to isolate the variable. You want to get it isolated all by itself. When you are solving for a variable, you must use inverse operations to isolate it one side. Okay, again, this is the whole addition, subtraction connection. If you want to undo addition, you do subtraction. Or it's also a connection between multiplication and division. If you want to undo division, you would do multiplication to get rid of it. Okay, so we want to get the variable by itself isolated, and we want to use inverse operations to make that happen. That leads us into the third rule. Whatever you do to one side, you must do to the other side. In other words, you must keep the equation balanced. They had that balance picture at the top of the first page. We want to keep things balanced, and that's why whatever we do to this side, we do to that side. Like if we're adding 4 to get rid of the minusing 4, we're going to add 4 to both sides because you want to keep things the same. Think of solving an equation like lifting weights. If you add or subtract weight from one side of the barbell, you must add or subtract the same amount of weight from the other side to keep it balanced. So whether you think of this as like barbells and lifting weights or a balance where both sides should be equal, that's really what's going on with solving one-step equations. And I'll remind you, just remember here, we're starting with these kinds of problems. Something divided by 2 is 16. Something times -2 is 18. Something plus 14 is 20. These always have one solution, but this is where it goes. Okay, you move into two-step equations, and eventually you move into multi-step equations, and you want to know how to get there. Okay, and the way we do that is we use inverse operations. All right, that brings this lesson to a close. You've been a great audience. See you later.